Alright, 14 we have e to the x cubed minus 2x squared minus 4x plus 5. And it says that f has a local minimum at x equals what? Well, ultimately this could only have a local minimum where we have the derivative equaling 0. So if we found the derivative would be itself. Times the derivative of the argument, 3x squared minus 4x minus 4. And we know that this can only equal 0. We know that thing never equals 0. It's e to something. This one equals 0. Hopefully it factors. Let's see, 2 and 2. Minus here, plus here. Plus 2, negative 6, that's 4. So we'd have a negative 2/3 and 2 as our two candidates. And if we number line those two. And really, in the scheme of things, if it's multiple choice, we don't really need to do this because we know that this is quadratic. So there's really no option for that other than plus minus plus. That's a parabola that opens up. It's going to have to be positive and then negative and then positive in terms of its values. Okay? If there are two zeros, okay? If there are two zeros, it has to look like that, doesn't it? So bottom line is not a multiple choice. We need to waste a bunch of time doing that. You might, but hopefully not. So bottom line is which one is where we have the local minimum as it asks? It's going to be at 2, isn't it? Derivative is negative before it, positive behind it. So correspond with letter E. What else? 1 through 14. 13 we have cosine x minus e to the 2x dx. And we have to find the antiderivative of that. So if we, I would handle these separately if I were you. We know the antiderivative of cosine is simply sine. When we have e to the 2x here, again, you can try, some of you might be able to do this u substitution in your head at this point, depending on how good you are at it, but bottom line is you can always u substitute here and get rid of that 2x. So we'd have 1/2 du, would be our, would equal our dx. So when we substitute, we'd have e to the u du now, and we'd have a half out in front. Again, we're going to replace the 2x with u. Dx needs to be gone. Dx is equal to 1/2 du. So we're going to replace it with 1/2 du. And our answer would be 1/2 e to the u, which would be 1/2 e to the 2x. Plus c. So it corresponds with letter B. In general, if we did this as e to the kx, wouldn't the antiderivative every time be 1 over k e to the kx? Yeah. Just like the derivative is k e to the kx, the antiderivative would be 1 over k e to the kx. So.
And do you have to stop right away?
As long as you get letter B, they don't really care what you do.
Okay. I just didn't know if I was that lucky or so that's
No, there's always, not always, but many problems there's multiple ways to approach it. You just need to do the one that you feel the most comfortable with, basically. What else? 1 through 14. What?
You have to do 5.
Nope.
Oh, yeah.
No.
Nope.
Oh,
So we got a bicyclist who rides along a straight road from home, time 0. Graph is shown above. The velocity is shown. That's what it says. How far from home is the bicyclist after 2 hours? Okay. So bottom line here is if we found the area between the curve and the x-axis here, okay, that would ultimately give us displacement, wouldn't it? Okay. Well, we can see that in the picture that we have a trapezoid for that first part. Okay. However, before we get to that 2-hour time frame, it goes negative, doesn't it? Okay. So with that said, we're going to need to be able to find essentially where it goes negative in order to calculate those areas properly. True? So if we look at it, it goes from the point 312. So 312 to, looks like it ends at 2 negative 6. Oh, sorry. Oh, it's, yeah, you're right. Sorry. So 1.5, 12, and then 2 negative 6. That looks good. All right, so if we do the negative 6 minus 12 here, 2 minus 1.5 here, we'd wind up with negative 18 on top and 0.5 on the bottom, which would ultimately give us a negative 36. Okay. So that being our slope, and if we put in our points here, I'll use the 2 negative 6 point here, so we get y plus 6, negative 36, x minus 2. Find the y-intercept of that. We get negative 36x, and these two would make 72. 72 minus 6 would be 66. Alright, and so ultimately the x-intercept of that then is going to be where y equals 0. So again, this is our line that represents that last line that goes through the x-axis. We want to know what that x-intercept is, so we know where this goes negative. So if we subtract, we get negative 66 equals negative 36x. We divide 66 over 36 equals x. Those two can both be divided by 6. We get 11/6. That's our answer for x. Alright, so at that point we would have enough information to figure out our point in question. Alright, and just to make sure it makes common sense here, 11/6 would be 1 5/6, which it looks like it's definitely bigger than 1 1/2, of course. 1 5/6 at least seems reasonable here at this point. So if we were to make that trapezoid then be 1/2 times the height here is 12. The two bases, the top base goes from 0.5 to 1.5, which would be 1. The bottom base goes from 1 to 11/6. Okay. And so if we find the area of that trapezoid, we get 6 here. And this would be, what, 17/6? And it turns out to be 17. Alright, and then, so again, that's the 17. So at that point, we would have went 17, but now we got to come back because we have a little bit of negative area to deal with, right? And so that triangle is going to be 1/2 times the base and height here. We know that the height part is 6. The base is going to be from 11/6 to 2, which would just be 1/6. Okay. And with that said, we'd get 1/2. So, and that would be negative, of course. And so, where would we be at in relationship to home? We'd be at 16.5. Our displacement would be exactly that, 16.5, which would be letter B. So again, in a picture like that, what's a very common mistake that people are going to make on the AP test on this that some of you know pretty well because you did it already before? Just going to guess that that's 1.75, right? So if they don't tell you that's 1.75, then is it 1.75? No, right? So make sure that if you have something like that, you need to calculate what that is by finding that equation for the line, right? You can't just say, well, it's close enough to halfway. Well, no, it's not close enough to halfway. It's not close enough at all, is it? Okay, what next? 10, we have our function f this time is cosine of 3 pi x squared, and we want the derivative at a third. So in general, the derivative here, derivative of cosine would be the outside function. Cosine's derivative would be negative sine of the argument times the derivative of the argument. Whoops, 6 pi x actually. So an x squared here, so it would be 6 pi x to the 1. And from there, we want the derivative at 1/3, it says. So negative sine of 3 pi, and this would be 1/3 squared, times 6 pi times a third. So, let's see if we can figure out what this is. So, and again, keep in mind that's the whole argument for the sine. When we get this all boiled down here, we'd have pi over 3. So you get pi over 9 here if we square it, times 3 would be pi over 3. So sine of pi over 3 we know is a half, so it would be negative 1/2 would be that part. And then this part here would be 2 pi. And ultimately, if we multiply those together, we get negative pi. Corresponds with letter E. Nope, I lied. This is not. That's negative 3 over radical 3 over 2. Sorry. Sine of pi over 3, that's the bigger y value at pi over 3. So it'd be radical 3 over 2, not 1/2. So that makes it 2 still cancel out. We'd have negative radical 3 pi. So that should be the answer, which corresponds with A. Excuse me. Questions on that one? What else? 1 through 14. On 11, they give us a function that's defined by piecewise. Looks like it's like a parabola and a line together, and it says first one here that f prime at 2 is defined. Okay, so do we have a derivative at 2 is the question. And what do we see at 2 going on?
Corner.
Looks like a corner, so that would definitely be a no on that one. What about 3? It says the limit as x approaches 2 from the right and left are the same. Do we have a limit at that point, in other words? Okay. There's definitely a limit there. They go to the same y value. There's not a derivative, but there is a limit. So 2 is good to go. And then in part 3, it says the derivative is less than 0 for all x in the open interval negative 1 to 2. So as we go from negative 1 to 2, is the derivative less than 0? In other words, is the function decreasing? Yeah. So therefore 2 and 3 would be good to go. The letter D. Anything else, 1 through 14?